My project is a fully functional remote-controlled model hovercraft. We strove to improve upon the basic hovercraft design with added features that enhance the user experience and provide additional protective features. The baseline goal of the project is to design and build all standard functionality of a typical hovercraft, such as the ability to move forwards, backwards, have speed control, and turn side to side using a remote control. The supplemental features include a crash avoidance system that uses a sonar to detect obstacles such as a wall, and an LCD screen to display the hovercraft's speed and battery usage. The secondary goal was to produce all of the core structural components using 3D printing technology, leveraging CAD design software. We are all lucky that Mr. Hofstadter was able to arrange such a great practicum with the engineering company GLENDIMPLEX. I learned a lot about the design thinking process and how to implement new ideas into pre-existing products. Another important aspect of my hovercraft project was determining part compatibility. My research included reading academic papers and referencing a former SMCS student, Benjamin Couric, for advice. The most challenging part of my project would definitely be the coronavirus implications. Due to the quarantine, my teammate, Max DIZY, and I have not been able to actually meet to build the final product. The robotics course requirements were adjusted only to build a virtual copy. However, my teammate and I agreed to finish the real-life build during the summer. I learned a lot about the principles of design thinking and how much work goes into an engineering project. I also learned a lot about working in a team environment and how to effectively collaborate in an engineering environment. Given the circumstances with the coronavirus lockdown, I would say the most rewarding part so far was the fact that Father Leung had the confidence in us to produce this hovercraft, such that he gave us a grant to cover the costs of all the parts.
Hello, I'm Max DIZY. I'm in the grade 12 robotics program with Mr. Hofstadter, and me and my partner have decided to make a hovercraft for our CPT robot. We decided to make this because Mr. Hofstadter challenged us to make a hovercraft better than the store-bought one he got for his son, which broke when he rammed it into a wall. What really allowed us to be able to build this and fabricate this was our multiple practicums at GLENDIMPLEX. This really allowed us to see real-life engineering and the engineering process, which was crucial in being able to fabricate this. And on top of that, just the extensive support from Mr. Hofstadter in class and his answering of all our questions, which really allowed us to fabricate this robot. So the first part of the engineering process after deciding what robot we wanted to build was the design process. So in our grade 12 robotics class, we used Fusion 360. This is a 3D CAD software which allows us to design and print all the parts that we need. So as you can see, we went through a couple different models trying to figure out which was going to work the best and be the most compatible with the other parts we were using, and we finally decided to use this model right here. What this model does is focus all the air from this single fan into both the skirt and the air pocket, which will be under the hovercraft. And this is how it actually hovers above the land. And then we have a whole other motor that's focusing on propulsion, which is going to allow it to go a bit faster than it would if we were only using one motor. This design process was probably one of the hardest parts of the entire process. This is just because this is the largest 3D model I've ever made, and every part in it needs to work with each other part for it to operate correctly. But now that it's finished, we can go 3D print it. After I finish the Fusion 360 design, I can then come down here and 3D print the parts. I am lucky enough to have a 3D printer in my house, which makes this process possible and also allows me to make multiple designs and try them out to see which works best. Once the 3D printer is finished, I can then take all the parts, bring it down here, and put it together with the electronics. Unfortunately, due to COVID-19, there have been some shipping delays, so I do not have all the parts I need yet. But I have taken all the parts that I've received and put it together so far. In this process, I have learned a ton about expanding my Fusion 360 design skills, programming a remote control to a receiver and controlling electronics, and as well as soldering, which is necessary for the circuitry of the robot. Probably the most rewarding part so far was controlling the servo motor with the remote control. This is pretty cool because it kind of showed me what the final project can look like and how to control motors with the remote control. I'm very excited to receive the rest of my parts and finish the robot, which will be displayed outside the robotics room.